Okay, so let's take a look at the presentation I've worked so tediously at for you. And where's the discussion of my modeling programs? Here they are. We'll start on this slide. Where's it going? When I move it, it goes away. Let's go full screen. And play my presenter view on my other screen. And we'll hit F11, full screen. So this is where we stopped off last time. We talked about class diagrams. This is the proper parent-child relationship. Their parent-child objects I didn't find a very clear example. Implied parent-child, although they really weren't parent-child objects. Here is a true parent-child object. Do you see the connection there between the two? That the parent here, everybody, well, there's multiple classes that are of type employee. That is the parent class. The only reason to have a parent class is if you're intending to have more than one child. If there's the only thing you have in your system are instructors, there's no reason to have employee instructor class. You just have instructors. But if you're going to have instructors and then you think, well, we're going to have administrators, well, we have to keep track of them, and they're not the same as an instructor. What do we keep track of for an instructor? Well, we have different methods for an instructor. Actually, we only have, in this case, we only have one different attribute in an instructor different from an employee. We add the type of instructor. Can you think of other attributes or methods specific to an instructor in this particular case? Looks like we're talking about a school. What would be additional attributes besides type of instructor that's an employee? Can you think of an attribute that would be unique to an instructor in this particular model of a
schedule?
What do you mean by schedule? Would it be a method or attribute?
It would be an attribute.
So like the schedule of the instructors?
Yeah.
Okay. Abby, do you have one?
What does it mean by like type of instructor? Does it mean like what department?
Yeah, that's a good question. I'm assuming what kind of I suppose I guess what their specialty is. That's the only thing I could think of. They could be adjunct, I suppose. You could be full-time or adjunct. It doesn't say there, so it's a little foggy. And that's where you would define this in the data sheet that go with the class. This is in the modeling. You would list these attributes, and in a special document of the data sheet explaining all of these things, you might say type of instructor means such and such. So the data dictionary or the documentation of this class would explain that. Method, I might have a method of enroll students or grade students or finalize the course grades. Those are the methods that I would expect the instructor class to have specific to them. Anything specific to an instructor you'd put in the child class. Anything that all employees can do, such as receive pay or request check or request time off, or they have pay rate. You might have overtime rate. Type of employee might be full-time or part-time. That would be more general. So the general things you put in parents, the specific things go in child. And if you've done object-oriented programming, you learn that inheritance, and it's all kind of foggy at first as you get started, but the whole idea of inheritance means things that are general to everything you put in the parent, and of course you keep it efficient by, if you ever make code changes in the general things, you fix the code or broken the code for everyone that inherits that same class. But it's very efficient. You make the fix in one place. You're not copy pasting code to all the other things that are similar. You have this inheritance idea. So in the coding, this makes a great it aligns very well with coding because you have object-oriented programming. And I think that's one of the big reasons object-oriented modeling is a big deal, because it's very close to the programming style. So if you're thinking of a software system, modeling with the object-oriented kind of gets you headed in the right direction of what your code should look like. Probably doesn't make a lot of sense if you're building a building or manufacturing something. Object-oriented doesn't feel as natural as perhaps the data flow diagram, where the data is the product that I'm producing. So your model choice depends on what your system is. And that's the point of going back to this table that was way back in chapter 1. Now that we're looking at object-oriented analysis, remember, that's just one way of a structured approach to building a system. The structured analysis is the old school, it's well known, and it has 5 well-defined phases. It's been around for a long time, and there's measuring of progress along the way. That's a big deal for managers and anyone watching the spending. You have milestones, measured progress. You have the 5 well-known phases of patio. What are the 5 phases? Planning, analysis, design, implementation, operation. Here they have testing and maintenance as the phase. But remember those 5 phases, well defined, been around forever. Building buildings, building something in sequence is often the way you have to do things. Object-oriented comes around. It's very thinking of focused on the objects in the system, and thinking about data and processes in the system. And remember, objects can be anything. Can be actual people, can be virtual kind of things, transaction events in the systems. But you treat everything as an object, and they say it tends to be more interactive, whatever that means. Interactive with the developers, I suppose. You can use the waterfall approach in your object-oriented analysis. Basically, sequential things happening in the object-oriented analysis. Agile is a big popular one today because it's team-based, intense team-based effort. You've got the focus on iterations and incremental steps in short time intervals. Let's think about that. What are the risks you're helping to reduce by going incrementally in short time intervals? What risks are you reducing?
Big updates.
Big updates? Yeah, you're doing small updates along the way, fixing bugs little by little. Little bit of like a divide and conquer approach. What's another risk when you're building especially in software? What's a risk? You're developing software and you want to deliver it in October. What could happen between now and next October?
Nuclear winter.
What's that?
Nuclear winter.
Nuclear winter. could be. How about people decide they want other software? The market changes. Does that happen with software? Very quickly. And that's the scary part about being in software, is suddenly the market, there's all the rage about something else. Some customers are very dedicated. They love your product and they'll stick with it forever. I don't think that's the case so much anymore. Yes, Abby?
Wouldn't like agile methods, like wouldn't it allow for like more bugs to slip through the cracks because it isn't potentially being tested as long?
Yeah. That's one of the risks of agile. That is correct. But the one major advantage of it is you can react to changing customer need, to change in technology. New processors out there, or a new graphics processor. Suddenly you can do a lot more in the graphics. Oh, we need to incorporate that. Oh, that requires a rewrite. Well, you haven't broken your system. You can adjust to the changes. So that's the general description. The tools you use in the structured analysis, we're learning some of them, the data flow diagrams, where in this case, and now in this chapter, we're doing object-oriented diagrams. Sometimes they use business process modeling. So we're focusing on this right now, that the modeling tools are diagrams using objects. In Agile methods, basically it's anything that facilitates good communication. So there's not specific tools for Agile. You could, and remember that you can mix these together. So you may have people that say we're doing Agile, but you come and you see all sorts of object-oriented diagrams. Well, they're incorporating diagrams because that facilitates communication. So Agile, they can use whatever tools help everyone understand what they're doing. So they may use business process modeling, just like structured analysis might use business process modeling. So this can also use business process modeling. Here is a good way to look at them, the pros and cons. And Abby, you mentioned that yes, bugs might get through, so they require, one con of the Agile is lack of structure and documentation can introduce risk factors. So you better have a high level of technical and communication skills. This is why in a lot of my assignments I'm making you write well formatted technical reports and documentation. I can't stress that enough. And we have had alumni come back and saying they realized when they got the job how important it was to communicate well. So your boss knows what you're doing, so your team knows what you're doing. I think it was Spencer Schuett that mentioned that. And he's not the only one. When you get a job, it's amazing how much, if you write well and practice writing well, not like super intelligent content, but well organized content, even if you're saying pretty basic things, organizing it well, it's amazing how poor people communicate out there. Even these diagrams, doing even a diagram, if you have the right things on there, but organize it nicely so it looks nice, that puts your work a step above everyone else's. Even if you're not diagramming that much, but you make sure it's a nice, clear, and neat diagram, it's amazing how some people just ignore that. They write like third graders, literally. I've seen very smart technical people. You can't hardly, their diagrams are all like crayon diagrams, and they have the information there, but it's like, why did we hire this person? And then you realize, okay, they really are smart, but boy, that diagram or that document didn't show that. And what happens is, if you have really smart people that can't document, the manager will make sure that they have a really good documenter working with that person to help rewrite their poorly written documents, but may have really important information in there, but that poor person doesn't know how to communicate well. If you find someone that can help you communicate well, like an editor or a critique. This is one thing great about many marriages, is that one spouse helps critique the other and helps them more clearly communicate things. My wife is very good at that, where I'll just say one thing and she'll say, saying it that way might make somebody pretty uptight because they might take it this way. So communication skills, and that's one of the big risk factors of Agile. You can be very, very agile and respond to market, but you better be careful about scope creep and bugs slipping through, because you're doing a quick iteration and you run to the next and leave behind perhaps lack of testing, because that was 2 phases ago and it's now built into your system. So it's very flexible, that's one big advantage, but there are higher risks. You've got to really have some people willing to learn and technical people that can clearly communicate. The object-oriented, they say it's somewhat newer, so development people may have a problem. And if you have a complex system, that whole class diagram, those can be complex and confusing, and it may just snowball into huge diagrams. So you got to be careful about that. But it does help you produce code if you do it right. Modular and reusable code. Those are wonderful things to do with code. The structured, it's traditional, so well known, and been very popular. Again, there's documentation. has to be well done. It relies on that because that's the specifications for what we're building. Changes can be costly though, because all that documentation has to change if you make a change in what you're building. Software you can rebuild. A building, you can't go rebuild without a huge cost. With software, you can iterate and say, hey, we're moving to a new OS, or there's a big OS change that came in. Usually you can respond to that in software. So it depends on what kind of project you're doing. Okay, now back down to our various diagrams, and this is described in the homework for this, and I thought I'd help you with that because in your homework for this particular chapter, I'll go over to there. In your homework for this chapter, we're asking you to create these 4 diagrams. An object relationship diagram. I'm asking you to create an object relationship diagram for your system. And how would I know what to create for my system? If you look at the description in the homework, I state you may use AI to help with this, but you must document your query phrase you're using. Let me demonstrate. I'm over here on ChatGPT, and bring over that window. Come over here, window. Here we go. Over here in ChatGPT, and I've asked ChatGPT, here's my message phrase, describes the object in an object-oriented model of a payroll system. Now you can try Gemini, see if it gives you a different answer. In case you're not sure, well, what objects make sense in a payroll system? And look, it actually came up the only information I give it was it's a payroll system and I want an object-oriented model and describe the objects. So now I can get on the idea, well, I can have an employee object, a payroll object. Notice it doesn't have to be another person, it could be a piece of the system. A timesheet object, a tax calculator object, that has to do with payroll, a payment method object, a benefits object. Wouldn't have thought of that. A pay slip, or maybe a paycheck, and a department, and a leave object. So they came up with that with multiple objects. If I'm not sure about that, I could ask Gemini and see if it came up with something similar. But this will at least let me get started. Okay, I would draw a circle, or have a shape for each of these objects. And somewhere in my documentation, I said, hey, the list of objects was suggested by ChatGPT using this particular query phrase. Let's give that same query phrase just for fun here. I'm gonna go over to Gemini, and let's see if Gemini gives me a similar list. And paste. Employee, paycheck instead of pay slip. Oh, department job deduction time card. So they gave a different list of objects. And they do have a benefit, a tax table, payroll processors. They don't have anything about leave. So it might be fun just to see which AI gives you what you think is a more meaningful answer. And this is legit research, just learning which AI actually gives more helpful information. Want to try Bing, Copilot? Is it I think Bing.
It's Copilot.
Is it Copilot.com?
Or you can click on that Copilot.
Or I can just click on Copilot. It does take me to Copilot.cloud. And let's see what phrase answer it gives me. So I give it the exact same phrase, describe the object and object or model of a payroll system. Now you could replace payroll system with how you might describe our Bible library system.
Wow.
Tax, benefits, timesheet, department, payroll, employee. So it gives you a list of objects. And I did say describe, so it actually, instead of just give me, I could have said list the objects, I might have got a shorter answer. Describe gives me an idea of what the attributes inside might be. Now in your homework, I'm not asking you for the attributes. I'm just asking you to produce a class diagram that looks like this, or sorry, an object diagram. So you don't have to put all those details inside of it that this guy showed me. This just gives me an idea of the objects that make sense. So you could give the same question and say, instead of a payroll system, what's, if I said Bible read, could I say Bible reading app? See what it gave me. Or I could say, let's say, or a document, let's say I try Bible reader. Like Logos. User Bible book, chapter, annotation, search, library. Look, it gives me lots of ideas for objects. Oh, a reading plan. I haven't even thought of a reading plan. Reading session. And so it came up with 10 objects. You don't have to use all of them, but if you're kind of lost on what objects would be involved, you're welcome to ask AI for objects. And let's see if I change it from describe to just list. What was my phrase again? I asked it to describe. I could just say list them. I might have gotten a shorter message. So that's instead of describe, let's just do list in a Bible reader package like Logos. Let's change it to BibleWorks to give you a different answer. There it gives me the object. It does suggest methods, but it doesn't give me the list. So if you're stuck with what objects to put, you are welcome to get a list. Just mention the particular phrase and what AI you used, and then just draw those objects and think what the relationship is. I don't think they describe the relationships. You could say, well, describe relationships between them. You know, you could even see, will it give me a class diagram? If it does enough to give you a class diagram, it looks like it's attempting to give me a class diagram. I'm not sure what it's doing right now. Give me lots of lines. Forever and ever. Not a terribly useful class diagram. Not sure what had happened to it. But it did give me those same objects that it had listed up here. Not all the objects, it just gave me the 4 of them. So not terribly helpful with class diagram. But this is the kind of thing, or object relationship, I'm sorry, I should have said object relationship diagram. Let's try object relationship diagram. Maybe I'll get something more meaningful now. Oh, the same forever. So Copilot let me down there. I think I'd say that's a little bug in Copilot. But this is what we're looking for. And I'm not going to be super fussy on this. Notice this is kind of describing the relationship between these child objects and employee. Remember that the inheritance and objects. In yours, let's see, we have an instructor teaches a fitness class. Say we went to this one, we'll go back to our list of objects here that I like ChatGPT. An employee, oh, which one did we ask for the Bible? The relationship when we use it. User requests or reads or accesses a Bible or accesses a book, chooses a Bible version, and then requests a specific chapter, and then reads that or browses the book, requests a specific chapter. I'm not going to be fussy on what you actually put on the verbs between the objects. Just kind of take a stab at what the verb might be. I would just basically draw a little box for each little object that you come up with that would go in a Bible reading application, and then see if you can, do some relationships between them. And PowerPoint makes the connectors. I saw Draw.io, Lucidchart are available. Let's see if I have other examples of I don't have other examples of an object relationship diagram. But I can see where you kind of get lost in what are the objects, and that's why I'm suggesting you can get a little help. What would the objects be? Think to yourself what objects are in a interaction with a Bible browsing software. They didn't mention the administrator that configures the system or the librarian. I would add our own discussion where we not only have the user interacting, but the librarian interacts with the system. So AI didn't give me a librarian. I'd probably put a librarian and maybe a sysadmin that's configuring the library for the user. And on the user side, you have customers, call them a customer, just call them a user or a reader. And inside your system, list pieces of the system that make sense, that have some relationship, and could possibly be treated as an object. Because remember here, I'm not expecting you to be super exact in your diagramming of your system, but a rough guess of what an object diagram, an object relationship diagram would look like. Just to give you practice on developing an object relationship diagram. That sound easy enough? So make up a list. My general approach to AI is it gives me ideas, but I don't copy paste what it gives me. That's, first of all, it doesn't help me learn anything. Anybody can copy paste. I like to see, I don't even compare the AIs. Do they give me better ideas? And then think to myself, okay, what else did they not mention? Because I didn't give it the full phrase, or I know there's a librarian that we already have talked about. There could be a tester. There could be a reviewer. So many possibilities for the different objects in any system. And at some point, you sit down with the whole team and you brainstorm, and people say, that's not a valid object. It's encapsulated in this more general object. But as a team building a big system, sitting around discussing this helps everyone, again, get on the same page of what goes into the system. Now, the other piece of the homework was a use case diagram. It basically helps everyone think about the steps in a specific function. Something happens in the system. How do we describe the interaction in a way that's very easy for my customer to understand as I describe, is this what you want my system to do? And to describe to the programmers or the developers, here is what the customer wants the system to do in a very general way. So here's your use case. I simply describe who is interacting with my system and what is happening when that user interacts. This is the most simple use case diagram ever. One particular actor and one particular use case, meaning one thing they do with my system, one interaction with my system. So the arrow doesn't say anything. It's what is happening in that particular case of interaction with my system. So let's get a little more complicated than the simple patient making an appointment in a medical office system. There's a lot more things that happen, right? The doctor has to be available, and the clerk has to confirm it, and the system is set to initiate a call to you the day before the appointment. All of that is set up in the make appointment. But that would be perhaps a more detailed use case. Here's another use case this came from the book, where a student is adding a fitness class. Well, there's some other case in the system where we somehow produce the fitness class roster of how many people are in it, and it interacts with the fitness class is available. Now we have a roster available for it. An instructor interacts to find out or to change their availability of when they can be scheduled, when their classes can be scheduled. And there is another process that interacts with that change availability system. Remember, I could have the same thing included in an object relationship diagram, but this is another way of looking at what has to happen to make this process work. Two slightly more complicated use case. So a student adds a class, produce fitness class roster. uses the result of the add fitness class. So it uses the result of this process, and it generates a new roster. An instructor changes their availability. The updated instructor information uses that information and updates the instructor's information. The documentation of the use case is clearly defined for the coder then to know, okay, what does the code need to do in this particular use case? So again, another way of modeling how the system needs to work. Here, instead of describing my attributes and methods, I describe, well, in more general terms, here's what has to happen. The programmer might actually turn this into an object-oriented, even a process flow diagram or a flow chart based on what needs to happen. That's up to the programmer, but at least this is defined by the request from the customer, because they don't know code. They just know here's what needs to happen when I have this interaction. So it's basically a visual for the people that are visual learners of things that need to happen. Here we have a boundary around your system. Here's what the system does. Kind of like the data flow diagram, I have my entities interacting with my system. Instead of, well, similar to the data flow diagram, the information I'm requesting or giving to the system from these external entities or actors. And here's what my system does inside. We're not describing data flow, we're describing what the process needs to do, but similar to data flow. And when this process is done, this person is notified, this actor is notified of the job that they have to do. That actor, mechanic, performs the work, and the prepare invoice process in our system then takes over. So the boundary of the system is that gray box. A couple other examples I found online that this one had a lot of notation on it. Here we have a customer that's checking out, and the subsystem with the boundary around it is my checkout subsystem. Look at that, we even have a little help process. Customer initiates the checkout process. The clerk is involved. It's not clear what the clerk does, but the clerk verifies or helps enter the information. The payment process is made as a result of the checkout process being concluded. And the payment then interacts with some payment service online. The clerk may have some interaction to verify. And then notice there's not a connection between this. There's another thing happens in the system that's related, that has an administrator managing our users. And notice the interaction with the administrator strictly, in this case, just the manage users part. The user, the customer actor, interacts just with the checkout process. These are in our system, and this shows my clerk just interacting with the checkout process. The payment process only interacts with the payment service actor, and I'm not sure why they put a picture instead of a stick figure for my payment service. And lots of other annotation from this diagram from another textbook. Don't worry about memorizing all that. That'll come as you actually do a specific system. Here's another one. Similar, we have multiple customers. Some are registered, some are new customers, and you see that the interaction with the system is a little different. For a new customer, to become a web customer, it looks like they have to go to the client register. They can view items in the system, but they don't have the ability to make purchases until they're a registered customer. I'm not sure what the arrow to web customer is really telling us. I guess they're saying once they're a web customer, they can be either new or registered to be able to do things. Not clear what they mean by this extra little layer. But we see little actors interacting with our system. Again, just one way of describing in general terms how my system is working. Because you know, a picture is worth 1,000 words, according to the theory. So an identity provider helps interact with, why would they interact with the view items? I'm not sure what this actor is particularly doing. I'm assuming they are verifying the identity of the customer to allow them to continue their payment. Somehow, they somehow interact with the view items part. I'm not sure what that's about. The credit service, yeah, they verify the credit for the purchase. PayPal would receive the payment or transfer the payment into the checkout process. Notice PayPal or credit payment service both interact, I would say, in the same way. And this feels like my login for this person before they can buy something. Not sure what they mean by identity provider. Could even be the identity of the vendor, or they actually have a product shippable, all that. And that's something that would be described in the documentation of each of these actors. But the big picture is, here's different actors that interact with my online shopping subsystem. Notice I'm not showing my administrator. You could add an administrator. That would be manage items, manage inventory. You could have shipping that updates inventory and does the delivery. We haven't listed delivery here. We just say they pay out, they pay, maybe it's a downloadable product. That's all some extra actors. We may have a more detailed use case for the whole delivery side of it. The class diagram, they mentioned that in the book. I'm not going to have you do a class diagram because they have to do with the whole database relationships between the data stores. It's useful to be familiar with because databases are often involved in your systems. So, but I'm not asking you to make one for this particular case, for this particular homework. But as you have data in your system, databases need, especially if they're relational databases, you need to know the relationships between the tables in order to design your data storage. And even if you're not doing specific, strictly relational database, again, defining how things work in this method helps your data handling people to understand where the data is, what is the proper, what does it mean, that what am I storing in my system, and how is it related to how the system is supposed to work. This describes the information and even the relationship between objects. I find it's more useful, the whole relationship thing. We see it mostly when you're dealing with the databases. So this is our the class diagram. Here's another class diagram, again implying tables of these names in my database, relationships between them, makes it clear to my database designers what tables we need to have and what the relationships are between them. And anything in the big blue is the name of the table. Anything on the one side of a relationship, that would be the primary key in that particular table. And we have all sorts of fun with this kind of stuff in the database modeling. But this basically says, with the documentation from this, you can basically create and design all your tables. If this documentation is clear and complete, it's like falling off a log to then, oh, here's a table. I know what fields I put in my table. There might be some extra, write the code for the methods, write my stored procedures, but I have the relationship between my classes. If I'm thinking of coding, well, it's not database so much as what my class has in it in my defined code, and then I write procedures that reflect this type of relationship. The sequence diagram is a way of describing what order things have to happen when I'm doing something in my system. And parts of the sequence diagram aren't super complex. You have lifelines. That's the time the object is interacting in the system. And let's see what that looks like. This is my lifeline of class 1, going from top to bottom. as it becomes, as it's needed at the point where this class is used in the code, it sends a message to class 2, and then that class 2 is doing something. At the same time, this process is still either waiting for a message to come back from class 2. This class 1 is active in my system. It might just be active and waiting for a return message from class 2. When class 2 returns a message, or a function in that class returns the calculation that it does, it's done being relevant to my process. The result is now processed by this class, stored in it, and I'm done with this code. It can be, the stack can be reduced. I'm done with that function, and this function continues on its merry way in my code. So it's sort of like a flow chart, but showing what happens in time in various pieces of my system. And remember, classes can be anything in my system. When is it active or alive doing it when some sequence of events is happening? So let's look at something more complex now after just the basics of what a sequence diagram looks like. Now, this is one I found online. I went to images.google.com and just looked for class or sequence diagrams. And I looked for some that kind of made sense. Here I'm initiating an action of checking my email. Well, the computer class has the send unsent email message to the server. Okay, the server now is alive in my particular action, and it is gathering up information about email and sending it. I'm making a new email to be sent. I send that to my server. I do get a response from that saying yes, it has been sent, or it has been queued up. I'm not sure why I don't get a message here of a response. Yes, that's now sent. But in this diagram, we're not documenting if that any type of message sent back. This one we show a response from the new email, and notice my server is active and then inactive while I'm doing something else here. And then if I click the send new email, download email, delete old email. Message is sent to the server and an undocumented response. I think for a complete diagram here, I would have a response from each process. To me, it just makes sense that when the server is done, it tells me something, even though it might just be a confirm that it has been sent. So I think they're missing a response each time, but it's describing what happens in time. I'm processing my email is active this whole time. This server is active only when I'm interacting with it, and in a certain time sequence. So remember, the sequence diagram basically emphasizes how things happen in order as I'm doing a specific thing in my system. Two classes, objects, computer, and server. Here's another example where what am I doing? I am accessing my music app on my device, and it's going to send me music based on what it thinks I would like to listen to. So the device activates the application, opens it. The user opens the application. The device starts the application that accesses my webcams. Another process grabs a photo and does a little AI processing on it, verifies that's me, finds my face, and in my database retrieves the mood. Somehow detects my face and retrieves the mood associated with that particular face, if I'm frowning or happy or feel like listening to a particular kind of music. I'm not sure what this is about, but I retrieve mood from a database. It sends me the mood. It displays me the mood. And based on the mood that it's displaying to me, it also goes and retrieves music Now I'm not sure what's happening here. I think they're missing this device is active here, because how can something that's not active be sending a message? I think there's a missing box here. Maybe this box needed to be stretched down further. That this device is active in my application when these things are happening. I think this is what this should be showing. That this device is active, and now the database again retrieves music. Now the device is playing my playlist, and my user either receives the playlist or listens to my playlist. Depends on what this means. So, example sequence diagram of some device that's doing most of the work. The user is interacting by just having the camera detects their face, gets it from the user, and then final action is the user gets a playlist, and I think the device will still be active. The database is only accessed in pieces of that sequence of events. I'm thinking if I'm playing music, that then this device, that app would be active, because the playing of music is required for the application to be active. Another example here, I have a user logging into a system. So I have three actors, a user, system, and a database. About every system is going to have a database in there somewhere. So they provide login information. I think they made a mistake here. I think there should be a little box here, because the user, it does something. The system takes that, opens the database, process gets some result about, hey, did they give me the right password, returns that to my system. The system sends back to me information about the login and tells me that I've been rejected or accepted. So in order for that to receive information, I think they were supposed to put a little box there. I think they forgot to put the boxes of the user active. The user right here is waiting, and so we'll call that user not active. You could say, well, if the user is waiting, that is an action. You could have the user be interacting with the system the whole time, waiting or providing information. So you see that sequence of things just on the login with the three actors listed both top and bottom. Seems like a decent way to describe things that need to happen in a specific sequence. Now, depending on your team and how useful this is, you may say, yeah, sequence diagrams are useless to us. Some other person on the team that is very intense on the algorithms that are very time sensitive, to them sequence diagrams may be critical. That, hey, if things don't happen in the right order, things break, they'll use sequence diagrams when it's appropriate. And that's your choice as a team, which diagrams are most useful to us. In this course, we're teaching all the diagrams used, so you'll be familiar with it when someone mentions they want to do that. So I was asking you to give a sequence diagram, and you could think of just some simple process. Don't get super complex. Think of what sequence of things happen when a user goes to read a particular passage in the Bible. You want to take a look at that? I'm going to bring up, not Copilot, I'm going to go to my Drive by Google.com, and I'm going to go to my cs412 folder, Fall 2024, and I'm going to create a new diagram. I found that I can do new here and go in more, and I can create a draw.io. I discovered I do have draw.io available in my Emmaus account on Google's G Suite. Draw.io lets me create drawings, and look at this, down under UML I have sequence diagrams examples to use, and I can start with a example one, simple to complex, and build on it. So they're down there in the UML, or I could search for, let's see if I can search for sequence. Look at that, I can search for a sequence diagram and start with an example one, and then just replace boxes in there. So I'm going to I'll just choose this one. This looks like a decent one. and I'll click create. I'm going to give the diagram, I'll call it Bible Library. And maybe I'll call it, what's the sequence? I'll call it read book, read book, read Bible, read verses. And it creates one from that template that now I can modify. So here's my objects. I can zoom in and out with the scroll bar, and I can right click, move that guy around. And let's see, what are my objects? Double click, I can name that object. I'll call this my user. This one, what should I call that? This will be my, what would that object be? That would be my, I'll call it the reader object. How about the display object? And can I duplicate that, copy paste, and I'll call this one, how about I call this the text, let's call that the Bible object. Or we'll call it the book object. Okay, so, oops. I thought let's see if I double click, there we go. How about my action is open should I call it retrieve? I'll call it retrieve. I retrieve a passage. Well, I'm asking for the menu of passages. So what would my message be? Open. Open listing. In the display, I provide back a listing of the books. The user selects a book and chapter. And let's see here. I'm not sure what this double box means here. I'm thinking I'm going to get rid of that double box since I don't know what that means. Well, I'm going to get rid of that. I don't know what a double box means right next to my normal box. There we go, I have that. And I ask for a selected book and chapter. Now the display process goes and requests that from the book. Let's see if I can adjust the size of that. That is not needed until I request that chapter, and I'll send a message. Let's see if I can, click on that. Can I just draw a line? Look at that. I just draw a line and put it anywhere there. I will then put if I click on that, start typing, we'll put in a title. Look at that, select, but it puts it right on top of the line. How do I get the title? Oh, I guess I can start, I think I can move it. Let's start typing again. Chapter, verse. And now if I come back to that, yeah, the little yellow dot, I think I can move that up above the line. I'm learning to use draw.io. So it sends me back, I'm not sure what dotted versus solid means here. I'll go with solid. So I request a chapter. The book provides me the content. So I click on that arrow, drop back. And content or text of that book. And a little yellow dot lets me raise that up above the line. And I adjust that. I get it just to touch the edge. There we go. Oh. There. And then the display. And then the book. I'll call it. I suppose I could call that the book database. I look at it once. It likes to scale my connections. That's interesting. And then the display is done, and then I can continue here. I can continue reading my book. I'd say that's a decent sequence diagram of me simply retrieving a specific passage I want to read. If I want to call this the book database, or just call it the books or the library or the manuscripts. That's a little fancier name. I'll call that manuscripts. Sounds more intelligent. And there's a sequence diagram, just of the things that have to happen as I retrieve a book. First I get a listing. The display, I suppose it interacts with my catalog, so maybe I'll put in here, I'm going to see if I can add another box here where it needs to get a listing of the manuscripts. So let's see here, can I add one of these? Let's see how hard that would be. Suppose I could copy paste that. And I'll have that, draw a line from there to here. What it'll be, oh, how did I get there? And if I start moving it, nope. Moving it there, move it up and down, left and right. This will be request catalog. And then drawing back from here to here would be they completed the listings available, manuscripts that are available for reading. Available documents. Adjust the lifeline of this guy and figure out how to properly move things around. And don't worry if it doesn't make perfect sense, if you're missing parts. The idea is practice making a sequence diagram with a meaningful sequence of things. Now don't forget, if you do a sequence diagram, put a description text underneath here, this describing a specific activity. So for a caption, if you want to put that in Word, you could do a screenshot of this. It looks like, let's see if I could save this as, what can I save this as here? If I do a file, export as, I could export it as an image and then just paste that image into my Word doc. Don't paste it as don't give me a separate PDF. We want this to be in a Word doc. Let's see if I just paste it or export it as a PNG. It'll give that a name. It's going to put it in my drive. I'm hoping it's putting it in the same drive where I'm creating this document. I want to be sure it goes in my cs412 folder that I've just started the drawing in. That's the one I was in, and save it in that folder. I'm going to pick that folder, select that folder. It's not letting me select that folder. Why not? Select that folder. No items in this folder. It won't let me select it. There we go. And so it's going to save that to that location as an image. And I could download that, put it in my Word doc, or include it in a document of my use case diagram. But for an example, don't forget you need to put in a caption. If I want to do a caption here, let's see, is there text? Is there a text item in draw.io? Let's see here. I haven't played with this enough. Add, oh, there you go. Add text. There we go. Add text. And here we go. There's a text element. In the text element, something of the description of, call this a sequence diagram of the user requesting or accessing a listing of items, then selecting a passage for display. And that would be my caption. You could do the caption here in the drawing, or do the caption underneath your image in the Word document. But don't forget to throw a caption in there. It's so easy just to throw images and say, okay, I'm done. You haven't communicated if you're not explaining what this image is. It's a sequence diagram of a particular activity. Does that make sense to you? Try to make this, just practice doing it without a lot of pain. State transition diagram. This is kind of a more mysterious thing, but I think you'll find it's, again, kind of helps you think through the flow chart. Let's look at what a state transition diagram is, and I have some examples of that too. Basically, how an object changes. Now it's like, what do you mean by that? How an object changes? And what is a state? Well, to me, the thinking of examples helps me understand this the best. So let's see what a state diagram might look like. Here I have states describing a account. Okay, what is the status of my account? Okay, an account is new, active or existing, or frozen, or closed. Now there may be other states of my account, like under suspicion, under investigation, lacking funds. We're just thinking about these 4 specific states and how they are related in what happens when the state changes from one to the other. So an account is new. I have just opened an account. We call it, it's not in the state of being active yet. We call it, it's just a new account sitting there in my system. One possible state of an account is, well, it could be active and or / existing. Well, it only becomes active or existing once I first make a deposit. And if it's active or existing, if it ever has to go to the frozen state, what caused it to go there? Well, somehow there were some assets attached. There's a lien on something, so or there's an investigation asset attached to it. It becomes a frozen, or in the state of being frozen. And if it ever is going to go back to active, well, this has to happen for it to go back to active. For it to be a closed account, still kept in our system, we don't just erase it because we have to produce records. Either the customer has closed it or the bank has closed it. 2 possible paths to becoming a closed account. So an account has 4 different states as described in this. And there may be other states we're not describing in this diagram. A way of another way of thinking about important possibilities in my system. How do I describe in a drawing way how it gets from one state to another? Here's another example of a CD player. It's either playing or stopped or paused. How does it get from play to pause? Well, I press the stop button. How does it get to play in the first place? Well, I press the play button to get into this possible state. How does it ever get to the pause state? Well, I have to have pressed the pause button. How do I get out of the pause state? Well, I press play. Okay, I'm playing. How does it ever get to the stopped? Well, I press the stop. And if it's stopped, how do I get to play again? I press play. What they haven't described here is I've played through all the selections and I'm done. That could also stop it. But that's not described here in this state diagram. So that may be something lacking, that to get to stopped, I could have another action of reaches the last element or the last selection on the CD. Unless there's another state of continuous play mode. But that would be added complexity to my state diagram. But a good problem might be take this and add the state of add the other actions that could get it to the stop state, and have a state of status of continuous play button has been pressed. Another example, a little more complex, where I'm in a state of logging in with my credit card. I've inserted my card, it's asking for a PIN. I'm now in the state of waiting for the PIN. The PIN has been entered to get me to my first try. If the PIN is not okay, I go to my second try. Same thing for third try. And the only state I can turn to after the third try is either they have access to the account or eat the card and shred it, because they entered the PIN 3 times, not in the incorrect PIN. Multiple states, and either access the account or destroy the card are the last possible states. Notice there's no way to get, there should probably be a release the card state, as maybe that's assumed as part of this. Access to the account, release the card. Not described here, but important states of activity in my system. I'm at an auction, I start a bid, or I enter something to be listed, it looks like. I've listed an element, it's in the listed state. No one's bidding on it, it's being ignored. It now becomes an ignored state after a certain amount of timer has expired. And it may be I choose to relist it, or it goes into the I'm out of this state, I'm no longer in this state, I'm deleted, and the item has been deleted, and now I'm outside this system. If a bid has been applied to it, it is now an active item because there is at least one bid. That event caused that. Now what can happen? More bids come in that are acceptable. That would be based on some other process, and either get sold based on the timer expired, or the buyer has hit the buy now. That could be another possible, depending on your type of bidding. And other things that happen is you notify the buyer and seller, and you enter the state of sold. You can decide in your system, does it get put in the archived for history, or do you delete the item and lose all information about that item? In this particular case, we leave this case state diagram, and we'll let the system handle what to do when it enters the state of sold and delete. Delete could mean delete from the active system, archive to my record system. And here's one that they had in the book where, again, I'm inserting my card, waits for the PIN. If it's accepted, they get cash. Notice there is no state of rejected PIN. That's not documented in this particular state diagram. They adjust their balance, I get the cash, and there's a possible change, and I always notify my customer about requesting the cash event having been requested. So the notifies the customer happens at the point where I request cash. So 2 things happen. I change the state. I'm not sure this is a proper state diagram, because the boxes should describe a state, not an action. So I'd say this is an activity diagram more than a state diagram. But it looks a lot like a state diagram. Here is the state diagram, the status of my items. So multiple types of items. I've only asked you in the homework to produce an object diagram, a sequence diagram, use case diagram, and a state transition. And I'm hoping this has helped you to kind of understand how they all work. And that's it for today.